All right, today we are taking what we know about quadratics, about solving, and all of those skills, and we're going to apply them to some of the area formulas that you guys learned in geometry. Now, these aren't necessarily going to be ones that you have to memorize per se, but we are going to look at how can we use those to solve different types of quadratic problems. So obviously, before we get started, we're going to review just basic solve type problem, and then we're going to get started. So pause your video and give this first Ignite a shot. All right, answer is up. So let's talk through this. So remember, when it comes to factoring, when it comes to solving, whenever there's a squared or something more than just a plain old x in there, or when they're mismatched. So like this one, I have an x squared and I have an x. If you can't necessarily go through and combine those, then we have to go ahead and factor this first. So for this one, in order to factor, the first thing that we do is we move all terms over to one side and get it equal to 0. So all I did here was I subtracted the 24 over, and then we start by going through the factor process. The first thing we always check for is a GCF. So for this one, that's why I divided by 4 next, because 4 is the largest number that goes into both 12, 28, and 24. Now, once you take that 4 out, remember the GCF goes on the outside and everything goes back on the inside of a set of parentheses. Once you take the 4 out, you really don't have to worry about that, at least while factoring what this piece right here. It just means that basically once 4 would be carried through at the very end. But now because this one, if I'm going to go ahead and factor this, you can really choose either guess and check, or you can choose factor by grouping. I chose to do factor by grouping because the a value, the 3, the number in front of the x squared, is larger than 1. So to factor by grouping, all we do is we take the a times the c, so the number in front of the squared variable and the number that doesn't have a variable. So if you take 3 times -6, we get -18. And really we say, okay, what multiplies to give me -18 that also adds to give me the middle term of -7x. So really, out of all the things that could multiply to get you 18, 1 and 18, 2 and 9, 3 and 6, the only numbers that could get you to 7 end up being 2 and -9. So what happens then is when we do the rewrite step, so if we go up here to the rewrite step, the first term stays the same and the last term stays the same. So we bring the 3x squared and we bring the -6. But in place of the -7x, that's where we put those two magic numbers. It becomes a +2x and a -9x. Now, those could be switched. It doesn't matter where you put them. The next step, though, is to group these first two terms together, and then group these two terms together, group these two terms together, and then continue the factor by grouping. All right. Now, be careful, because a lot of students just want to stop at the factored step. But this case, it didn't say factor, we said solve. So what we do is we take each of the individual factors. Now, I forgot to write one of them. Technically, that's not one. Technically, we would take the GCF and set it equal to 0 as well, because GCF is a greatest common factor. But if that greatest common factor doesn't actually have a variable, that isn't true. It just means it doesn't produce any solutions. So that's why I didn't write it in this case. If there had been like a 4x there, then that actually would have a solution. 4x equals 0, we would divide by 4, and x equals 0 would also be a factor. But that doesn't happen on this one, so don't worry about that here. But we take each of the factors, set them equal to 0, and we get x equals -2/3 and x equals +3, excuse me. Okay? Now, basically what we just did there is something we're going to apply to different types of some solving problems. An area is a perfect case of somewhere where we can use factoring in certain cases. Just because when we talk about area involves usually multiplying two things together. So for this first one, we're saying basic. It says find x if the area of the rectangle is 72. Now, to set up our problem, it might help to remember what exactly the area formula is for a rectangle. And it's either length times width or base times height. I think I use base times height more, but really they're the same thing. And that just means that's going to be our setup for how to write our equation. We know the area in this case is supposed to be 72. So that gets plugged in. We know the base, and honestly, it could be either one of those. Doesn't matter. Let's call this my base and this my height. And I'm going to plug in my different pieces. Plug in the base, plug in the height, and now we have to go through and solve. Now, the key that I'm noticing is that I can't solve right now. Because typically, if, like, for example, this 72, if this was a 0 right now, I could set each of these equal to 0 right now, and my answers are going to be -3 and -2. But because of the fact that my area is 72, that means I have a little more work to do. We actually have to multiply the right side out, subtract the 72 over, because we have to actually be equal to 0. So now some students would say, okay, well, Ms. Hardy, can't I subtract the 72 over now? Yeah. You can't do anything inside of the parentheses though yet. Because remember, multiplication would come before any addition or subtraction. So in order to go ahead and factor this, we actually have to multiply this piece out. So that actually is our next step. I'm going to take x times x. That's going to give me x squared. X times 2 is going to give me a 2x. I'm going to move on to the second set. So 3 times x is going to give me 3x. 3 times 2 is going to give me 6. And now let's just clean it up a little bit and combine our like terms. We have like terms here and here. So let's actually clean this up. We're going to be left with x squared. 2 plus 3x ends up being plus 5x. Oops, forgot squared. And 6 minus 72 is going to end up being -66. And now that it's equal to 0, now I can go, and all my like terms are combined. Now we can go through and we can factor. Now I'm just going to do guess and check, simply because my a value is 1. So really I just have to answer kind of 2 questions. We have to say, okay, well, what's going to multiply to give me a -66, but also add to give me a 5x? We're looking to answer these 2 questions. Ooh, wow, reverse that. To say, well, what multiplies to give me 66, but adds to give me 5? So let's start off by writing some of our factors. For 66 now, you might realize that we're going to reach our answers. We have to go through and kind of find all the factors of 66. So out of all the factors, we could obviously do 1 and 66. There's a lot of them. I could do 2 and 33. Obviously, none of those give me anywhere close to 5. So if you look at all the factors of 66 that could possibly get you to 5, the only answers to that, the only ones that end up working, the only one that ends up working ends up being 6 and 11. And if I want to get a +5 by adding and a negative by multiplying, that just tells me that, nope, now I want it. That just tells me that the 6 has to be negative. And that these 2 guys are my final answers. It's going to be x minus 6 and x plus 11. So to solve, again, it says find x if the area of the rectangle is 72. That means we want to solve. So that means we're going to take each piece, set these equal to 0, and now we solve. Here I'm going to add 6 to both sides. One of my answers is going to be x equals 6. And for the other one, I'm going to subtract 11 from both sides, and we get x equals -11. Now, there's 2 kinds of questions I can ask. If I just say solve, then we would stop and both of these would be answers. But we have to also keep in mind that this is a word problem. So we can't just go ahead and circle them right away, because we have to think about the fact that x should, at the end of the day, is going to be plugged in here and here. There might be some answers that wouldn't necessarily make sense. Like if I plug in -11, look at what happens. My base says I would do -11 plus 3. And you're going to notice that that does not give me a nice answer. That gives me -8 as an answer. Can you have a negative as a distance? Absolutely not. So what that tells us in this case, it tells us that x cannot equal -11. It just means that this doesn't end up being a solution for us, because this has that word problem connotation. The only thing that x can possibly be in this case is just x equals 6. So what I want you to do is I want you guys to try example 2. Now, I'm going to get you started simply because you're probably wondering, all right, Ms. Hardy, I don't know what the area of a trapezoid formula is, and I can help with that. So area of a trapezoid looks a little bit odd, and there's a lot of ways you can write it. When it comes to solving via fractions and solving and factoring and things like that, I'm going to write down probably the one that's going to help you the most. So area of a trapezoid is 1/2 of the height. That's supposed to be an H, sorry, not an N. So in this case, the height is always what is attached to this 90-degree symbol. And then you multiply it by the sum of the bases. So in trapezoid world, it doesn't matter which base is what. The bases, though, are the sides that are parallel to each other. So let's, for our purposes, let's call this one base 1, and we're going to call this one base 2. Okay? But I do want you to pause your video. I want you to try setting it up, and I want you to try solving. All right, process. You should have started off with these, okay? Your first step should have been to plug everything in. So area formula for a trapezoid says we take the area, and it's equal to 1/2 the height. So in this case, our height was x. And then it's when you add the bases together. So you should have done x plus 2 plus x plus 6. So all I did in my first step was I simplified what was on the inside, but then all I did was distribute the things out in front. So I took this 1/2 x and I multiplied it by 2x to get my 1x squared. And then I did 1/2 x times 8 to get me my 4x. Now, before you can go ahead and solve though, remember it has to be equal to 0. So then your next step should have been you subtracted the 32 over to the side with all of the other things, and then we factor. Now the nice thing about this one is because the a value in front is a 1, I just simply use guess and check. So I said, all right, well, what's going to multiply to give me negative 32? That's going to add to give me 4x. Well, or add to give me 4. The only options of things that ended up working would end up being 4 and 8. And to get a negative 32, one of those has to be negative. So in order to get a positive 4, it has to be the 4 that's negative. So all we did is then plug those in, and we go ahead and we solve. So you should have got x equals 4 or x equals negative 8. We have to actually go that extra step, and hopefully you checked. So like if I try plugging in x equals 4, well, let's see. 4 makes sense for a height, totally. If I do 4 plus 2, we get a base of 6 on top. And if I do 4 plus 6, we get a base of 10 on top. Since none of those heights are negative, that just tells us that the answer that we have here, x could equal 4. So let's try negative 8. Let's see if that one works. If I take negative 8, well, if I plug it into the first one, already it breaks our rules because we can't have a negative height. We can't have a negative value for a height. So that tells us that x equals negative 8 is not an answer. So be careful. It's not necessarily just because this is negative. That's not the real reason behind why it doesn't end up being an answer for us. It's not an answer because when I plug it in, it causes a height to be negative. So don't get caught up with the fact that, oh, this one's negative, it's not going to work. Sometimes it might work. It depends on the problem. So just be really careful kind of moving forward through that. Okay. Now, on the back, we do have one, if you look at this last example. This one I made you do a little bit more work because you have to write your equations. Now, the nice thing is that since we're dealing with a rectangular picture frame, it tells me that for sure I'm working with the formula for a rectangle. Now you have to do some work because we first need to find the actual length and the actual width that we are working with. So, let's read the problem first. So this says we have a rectangular picture frame with dimensions 12 inches by 16 inches. All right, so our picture frame really, if you look on the inside, it's really this inner rectangle going on here. It says if the whole picture area, picture and frame together, is 357 inches, what is the width of the frame if it is X inches long? So basically, if this is a kind of an even frame width all the way around, we're saying that the distance or the width of the frame is X inches. But in order to calculate the area, this area represents the frame and the picture. So to find my base and my height, that tells me that I need to know this entire distance. Let's call that our base. And I need to find out this entire distance, which we'll call our length. So we need to basically say, well, how far across is it? Let's start off with the base, for example. So to cover all the way from here all the way across to here? Well, part of that, so like for example, from this point right here to this point right here, I know for a fact how long that is. I know that this distance is 16 inches. This piece right here though, that's X inches long. That's the width of the frame. But then we also have the frame on the other side. So really the distance is all the way across. It's 16 inches plus the distance of the frame on each side. So let's clean this up just a little bit. So really the distance across, it's 16 plus X, which we can simplify. It's going to be 16 plus 2X. Same thing goes true for the length. The length, it's going to be the distance across. From here to here is 12, but then we also have a width of X and X on either side. We have two X's that have to be added to that. So our length should be something along the lines of we are going to take X plus X, which is going to end up being 2X, and then plus 12. Now for the base, just so you guys know, if you like writing the variables first, you can write them either way. It really doesn't matter. So length, I like writing the variables first. So let's do, I'm running out of room, but length is going to be equal to 2x plus 12. Now that we have my length and my base, and no, I used length. I meant height. I'm sorry, guys. You could do base and length, width and height. Doesn't really matter. I use B and H, so let's call this H. And kind of moving then on through the rest of this, if my height is 2x plus 12 and my base is 2x plus 16, now that what we can do is we can now plug those in. My base is 2x plus 16 and my height is 2x plus 12. And now this becomes pretty much like all the other problems. So we're going to start off with, I'm going to multiply this piece out right here. So 357, we're going to say, okay, it's going to become 2x times 2x. Why? 2x times 2x is going to end up becoming 4x squared. 2x times 12 is going to end up being 24x. 16 times 2 is going to end up being 32x. And last but not least, 16 times 12 is going to end up being 192. Which, in order for me to factor, that tells me I have to get all my like terms on the same side, and it has to be equal to 0. So I'm going to subtract 357 over. And now we're going to be here. We're going to take 0 equals. I'm going to kind of go through and combine my like terms as well. So I have a 24x plus 32x, which is going to end up being 56x. And then 192 minus 357 ends up being negative 165. Now we would start with a GCF, but fun fact, there isn't a GCF really larger than 1 that goes into all of these, which really tells me that we need to go through and do guess and check, or we not guess and check, that means we're not going to use guess and check because the A value is larger than 1. So to go through my factor by grouping, this is going to seem a little large, but I'm going to take my A value and we're going to multiply it by the C value. So these two pieces get multiplied together. And we really say, okay, well, what number is that? That's going to end up being 660, negative 660. And we're looking for any factors of 660 that have to multiply to get me 660, that also add to give me 56. If you go through all of those factors, the only ones that really end up getting you to 56 are going to be 10 and 66. And in order to get a negative multiplying, but they have to add to be positive 56, just tells me that the 10 has to be negative. So when it comes to grouping, what that means is the first term comes down, the last term comes down, and these two pieces, the two numbers that we just found, those become my middle terms. So we're going to do a negative 10x and a positive 66x. Again, order doesn't matter. So you could have switched the 10x and the 66x, but all of you guys, no matter which order you did it, we group the first two and we group the second two. And we basically find GCFs. GCF between a 4x and a 10, the largest number that goes into 4 and 10 is 2. And the most number of variables I can take out ends up being an x. So if I divide both of these by 2x, Then we're going to be left with basically a 2x minus 5. Now, if you do this correctly, whatever GCF you take out of the second set of parentheses, ideally you should get the same thing. So some students like to work backwards. They like to say, okay, well, what would I have to divide 66 by to get 2? Well, the only number that will work is positive 33. And the nice thing is, if you check, if I take this and divide by 33, we get our 2x. If I take 165 and I divide it by 33, you actually do get negative 5. And now we're factored. We're going to first factor is 2x minus 5. Second factor, we make up with the GCFs. It's going to end up being 2x plus 33. Now, last step that we have to do, we just now have to go through and solve. So 2x minus 5 equals 0. We're going to start by adding 5. We're going to be left with 2x equals 5. Divide by 2, divide by 2. X is going to be equal to 5/2. And last but not least, we're going to solve the other one. Oh, and I ran out of room, so I'm going to do it over here. 2. We're going to take 2x plus 33 equals 0. And I'm going to solve this guy. Oops, minus 33. 2x equals negative 33. And then I'm going to divide by 2 on both sides. Now, technically, this is the part where we would check. So we would say, okay, well, let's try plugging both of these in. Now, if x represents the frame distance, this is a case where right off the bat, I know that this one can't be it. Because you can't have a width. If x is the width, you can't have a width that's negative. So that just tells us that the width of our frame, we just want to make sure we answer the question. It says, what is the width of the frame? The width of the frame is 2.5. And then we're working in inches. So 2.5 inches long. Or long, wide. There we go. So if you want to try at the bottom, I put the area formula for our triangle, but if you want to try the You Try Now, pause your video now and I will write in the answer. You should have got x equals 12 on this one if you did this correctly. We won't be doing this in class, but all right. As always, guys, that's it for today. If you have any questions, feel free to reach out and email Miss Hardy.